Now, here's the thing. Not all elements have that ability to steal electrons from others. For example, I need to be over here. Thank you.
Oh, yeah, we're behind.
All right, hooks. I'm not hearing nothing.
What?
And that's a problem. Yes, and that's a problem. So the thing is, these elements over here, they're very close to being full. Everything here is just one electron away from being full, and so it will give up electrons really easily. All these things over here, fluorine, chlorine, bromine, acetylene, iodine, and acetylene, they are very close to being full also. All they have to do is gain one electron, and so they're very chemically reactive. They can take electrons like crazy. Who's got $1?
Me.
I need $1.
I have $1.
Like literally, I need $1. Yeah.
In my bag right there. Cash money.
Okay. So, all right. So here, I want you to hold this $1. You're gonna play the part of sodium.
See how fast I can boot game your ball?
All right, guys, ladies and gentlemen, yellow. We're at yellow right now here. We don't want to capture this on film. All right, so Reese is playing the part of sodium, and hold out your electron there. Not too
Electron.
tight, right? Because I'm chlorine, so I'm gonna take that.
Oh wow.
What about what I just said? What about what I just said resulted in not a even little bit of quietness happening here? Okay, thank you. So I just grabbed this. So we got to do this again because nobody was paying attention. Everybody's talking. So here's Reese. He's got this electron. He's sodium. I'm chlorine, and I got it. Now, see, if you're chlorine, you have a very strong ability. Everything over here has a really strong ability to just grab electrons away. And when you're sodium, you have a really strong ability to give up electrons. But let's say, and I see your hand. Let me just sort of finish my point here. Though let's see here. What if we were something else, like hydrogen and oxygen, for example? First of all, oxygen needs 2, right? How many does hydrogen need? Say 1. 1. Yeah, good. Very good.
1.
Hydrogen just needs 1 because that will make it like helium. If it gets 1 more, it'll be like helium. So that reminds me. How many hydrogens would we need to make a compound with oxygen then? 2. Yeah, right. Very good. 2. We'll show that. Yeah, we'll see that in just a second, right? H2O. But so here's the thing. If you're hydrogen and I'm oxygen, here, hold your electron again. I, as oxygen, am not quite as good. No, you gotta actually hold it this time. As oxygen, I'm not as good at taking these, and so what we're going to do is we're going to share it, actually. And that's what happens.
Sharing
Most
is
things,
caring.
See, some things on the periodic table are really good at taking and giving electrons, and they form ions. But other things, not so much. Almost everything in the middle parts of the periodic table, with the exception of this column and this column, they share electrons. They form what are called covalent bonds, where it's sort of like shared custody. It's like it's like we're divorced parents now. Okay, Reese and I are both divorced parents. It didn't work out, but we've got a child, and sometimes here, hold on. Now let go for a second. Sometimes the child's staying with me, sometimes the child's staying with him, sometimes the child's staying with me, sometimes the child's staying with him. They both have the electron. And it turns out that that's good enough since, and I'll give you your $1 back, since the electrons go back and forth between them so much. I'm going to show you this in just a second. Actually, I can, 1, 2, 3, 4, 5, 6, right? There's oxygen with its 6. But okay, so here's hydrogen here. Hydrogen has 1 electron, right? And so what happens with a covalent bond is that hydrogen, 2 hydrogens, right? Because we need 2 of them. Hydrogen pulls up alongside, and so now instead of these electrons just, for example, going around oxygen, they start to go around the whole thing. And also, this electron from hydrogen doesn't just go around hydrogen anymore. It starts to go around the whole, I'm just screwing this up. Hold on. Like that, like that, like that. Okay, there we go. Now it's kind of hypnotic, isn't it?
No.
That's all
No, and I just screwed it up. Well, the point is that the electron gets shared, and that was sort of,
It looks like clay.
it's not exactly how it happens, but the point is that the electron is shared, and that makes this what we call a molecule. The other things were ionic compounds between ions. This is a molecule with covalently bonded atoms, and so this is what you see in most living systems. I mean, we have ions in us, but the molecules that we're made of are mostly covalently bonded, and they're mostly covalently bonded with one particular thing, and this is where we're going to end today, is the carbon.
My arm's
Right?
getting tired.
The carbon is carbon's number 6. And, oh look, Reese, you're on TV.
Reese.
I was on TV before too.
Yes, you were.
wish I was on
So here's carbon,
You did good.
and it has,
I'd be good
Oh, my arm.
it's got 2 in the center, and then 4 on the outside, right? 1, 2, 3, 4. And so let me ask you this: what compound would be formed between the carbon and hydrogen? How many hydrogens do we need to make a bond between carbon and hydrogen? Say 4.
4.
Very good. Y'all are really on this today. Yeah, because if you think about it, carbon or hydrogen it needs one and it has one. And so if hydrogen makes 4 bonds to carbon, CH4 is the molecule, methane.
This could honestly go viral.
Yeah. CH4, methane, is the compound that would be made between carbon and hydrogen, and because, for those of you that are not getting this, what that means is that when you combine carbon's 4 that it started with in the outside with the ones that hydrogen brings, that makes 1, 2, 3, 4, 5, 6, 7, 8 for hydrogen. And even though it only has like partial custody, like we talked about, so the hydrogen only has those electrons part of the time, and the carbon only has those electrons part of the time, this shared custody, sharing of electrons arrangement means that they both sort of have them enough of the time. Don't forget, electrons move at, didn't we look this up in here?
2,200
Kilometers.
Kilometers
A second.
a second, yeah.
Which is really
That's a lot of
fast.
kilometers per second, ladies and
Not as fast as
gentlemen.
I
So it's
Yeah,
like,
that's-
imagine
that's
that, like,
not me
okay,
either.
that must mean, so that means and when we take that into the fact that an atom is like 10 to the 17th or 18th meter, minus 17th or 18th meters across,
Well, I some-
that means that those kids are going back and forth between mom and dad like a whole lot of times per second. It's like, oh God, I gotta visit my dad. I've already done it 18 million times this second. But imagine what Christmas is like. But anyway,
Christmas must be rough.
okay, I guess that's enough of that. All right, boom. Thank you.
Thanks again.